we're going to do some more linear equations. Solving some more linear equations. These couple of problems that we're going to do will use the law of operations, or the order of operations, much more heavily than the ones we've done. Done being in the last section. Okay, so suppose you have this problem. Let's clean up the left side. Let's clean up the right side. Combine like terms and take it from there. The left side, in terms of this, take away that. I know what the first term is. It's 3. Minus 3 minus 8x minus 10. There's an understood 1 there. Minus 1. Minus, so I'll distribute the minus 1. Minus 1 times 8x is minus 8x. Minus 1 times minus 10, or negative 1 times negative 10 is positive 10. 3 plus 10, 13, minus 8x. That's what the left side equals, all cleaned up. The right-hand side is 2 times what's in the brackets. Let's clean up what's in the bracket. In the first bracket, in the left side, there was nothing to do. But in the right bracket, we have to distribute, combine like terms. Like before, we can think of this as negative 1. Negative 1 times 2 is negative 2. Negative 1 times positive x is negative x. So we distribute. Now we will combine like terms. 3 minus 2 is 1. Don't forget to take away x. Now we distribute again. We have 2 times 1 is 2. 2 times negative x is negative 2x. Now, I believe we should bring the x to the side that has more x's. The left side has negative 8x's. The right side is negative 2. Negative 2 is bigger. So I'm going to bring all the x's to the right side. I'm going to bring the negative, I'm going to get rid of the negative 8x's on the left side. I'm going to have to do the same to the other side. If the right side is only going to have the x's, the right side is going to have the x's, then the left side is only going to have the numbers. One side has numbers, one side has x's. That is, I'm going to take away 2 from the left side, from the right side, so it is only x's. And I have to do the same to the left side. The left side is 13 minus 2, or 11. The right side is 6x. (11) divided by 6 will give me x. And I'm done. Let me line up the equal sign. 11 divided by 6 gives me x. And that's it. X is 11 over 16. Suppose we had this problem. 15 minus x plus 2 times 3 minus 2x, and this is equal to 3 times 4 minus 2 times x take away 1. Suppose you have this. Let's clean up the left side. It's this term minus this term plus that term. The first 2 terms are straightforward. 15 is 15 and x is x. Now, we can probably think of this as positive 2. Positive 2 times 3 is positive 6. And positive 2 times negative 2x is negative 4x. So, all our terms and this second line are all cleaned up. They're cleaned up. So let's combine like terms. 15 plus 6 is 21. This is understood to be negative 1x. If you take away 1x, then you take away 4 more x's, you took away 5 x's. The right-hand side is only one term. Remember, terms are separated by addition and subtraction symbols that are not inside parentheses. All our addition and subtraction symbols I see, they're in brackets. There is only one term. Let's identify the factors. It's 3 times what's in the brackets. So let us figure out, so 3 is 3. Let us figure out what is inside those brackets. Let us distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So I distribute everything. Now I can combine like terms. My goal is to just figure out what this factor is. 4 plus 2 is 6. Don't forget to take away 2x. Okay, now I can figure out the whole term. That is, now I can distribute the 3 to 3. The left side has more x's. If you bring the x's to the side that has the most, you'll never get negative x's. Students are forever messing this up. They'll divide, say, by 3. They'll say x is 7 over 3. Which is wrong. If you brought the x's to the other side, you would have 3 x's. If you brought the 7 to the other side, you would have negative 7. So if 3 x's is negative 7, you divide by 3, and you'll get the right answer. You wouldn't have an opportunity to have a negative number of x's. This is where you make your mistakes. I'm showing you how not to even get there. Forget about how to deal with it when you are there. You don't even have to get there. Negative 5 is bigger than negative 6. X's go to the left side. So I'm going to bring these x's to the left side. That is, they're no longer on the right-hand side. And if I'm bringing the x's to the left, I'm bringing the numbers to the right side. Negative 5 plus 6 is 1x, which is a friendly number of x's. Because I'm done now. I just have x. The right-hand side is negative 3. 18 take away 21. Well, do 21 take away 18? That's 3. But if you read it backwards, it's not 3, but rather negative 3. And that's it. If you brought the x's to the right side and the numbers to the left, you would have gotten 3 is equal to negative x. And then, if two quantities are equal, if 7 is equal to 7, then if you change their signs, they're still equal. If negative 7 equals negative 7, which it does, if you change both signs, they're equal. So, if this were my problem, if I got down to negative x equals 3 or 3 equals negative x, I would change this sign to positive because I want to have just x, and I would change the understood positive 3 to negative 3. That is, x is equal to negative 3. If you tell me negative x is equal to negative 7, I would change and change. X equals 7. If you told me negative x is equal to 4, I would change and change. X is equal to 4. Maybe it wouldn't matter so much if you had a negative number of x's if you understood what I just said. But in my opinion, that's just not taught at all. Generally, you're taught that if you have negative x is equal to some number like 7, you now come and you multiply both sides by negative 1, and you get x is equal to negative 7. Like I said, if I have negative x is equal to and understood positive 7, I would change that sign, and I would change that sign, and I go, boy, am I glad I'm done. X is equal to 7. This finishes the section that was entitled More Linear Equations. Good luck with